Are you able to understand? I think this is a very, very simple technique where I'm connecting a CN between base and the lower portion of your primary of the center tap transformer. And center tapping is usually grounded, so you ground it and other end of VCC is grounded. So one end of VCC is given to R1, R2 voltage divided bias. The other end of VCC is grounded commonly here. So in the circuit shown in the figure, you have the undesired effect of the collector to base capacitance, that is CBC. So CBC you cannot avoid because CBC is present automatically at high frequency, and this is indirectly becoming a feedback component. So I am going to cancel the effect of the CBC by introducing a signal which is going to effectively cancel the feedback signal of EBC. That is going to be the neutralizing capacitance CN. So a small variable capacitance CN is connected from the bottom of the coil to the base of the transistor. So it is a variable. So you can vary the capacitance and ensure that the feedback signal is completely cancelled out. So even if a slight feedback is available, it will disturb your circuit enormously. So I am having a variable capacitance CN here, which will ensure that all the potential oscillations which will arise because of the positive feedback generated by this capacitor CBC is completely cancelled by CN. I cannot make it fixed because you never know how much amount of feedback is generated. So a variable capacitance will do the trick for you. So the variable capacitance will also have a important role to see at what point the feedback cancellation happens perfectly. So for that only, instead of having a fixed capacitance Cn, I am having a variable capacitance Cn. Okay, this process is achieved by the neutralizing capacitance Cn. So it introduces a signal to the base of the transistor, which is going to cancel the signal which is fed by CBC. If CBC is going to have a feedback of say plus K, will provide minus K. If it is going to provide minus K, it is going to provide plus K. So completely opposite because they are connected to the two ends of the same coil. The center of the coil is grounded. So the polarity of the coil across the terminals are completely opposite. Okay. So generally a variable capacitance is used as CBC changes with time. So all these capacitances will vary with time, will vary with frequency, and will vary with the biasing DC biasing conditions. So that is the reason why, that is the reason, just a second, just a second. Okay. So that is the reason why we are not using a fixed capacitor, then we are having a variable capacitor because the CBC is going to vary with time. It's a time varying quantity. Okay. CBC is varying with time. So by properly adjusting Cn, you can achieve exact neutralization. So this is one method, Hazeltine neutralization, where using a capacitor itself, I'm going to cancel out the feedback which is generated by the internal capacitance of your transistor CBC. So that is achieved by using a capacitance Cn. Cn is called as neutralizing capacitance or neutralization capacitance. So the circuit may look big, but it is simple. You just have a common emitter amplifier tuned circuit, and the C2L, this will form the tuned circuit. This will generate the amplify the signal at a particular frequency, which is generated by your tuned amplifier. Okay, and this portion is where we introduce the neutralizing capacitance to cancel out the feedback portion of the signal. So one modification of this circuit is called as neutralization method, or it is called as modified Hazeltine method.